Hey everyone, what's up? Am I audible? I'll let everyone join in. Let's wait till everyone joins in. भाई ये न्यू हाउस है क्या? नहीं नहीं भाई, न्यू हाउस नहीं है, पुराना ही घर है. It's just the background has changed, nothing else. Yeah, I'm on time. I'm on time. Let's wait till everyone joins in. Looks like people did not expect me on time, so there's less audience. Thank you, Ashish. Everyone join in. No recap, no recap. So, how many of you did not attend the morning class? How many of you did attend the न्यू आईफोन? क्यों लेना है न्यू आईफोन? जबरदस्ती क्यों लेना है? चल तो रहा है इतना अच्छा. एवरीवन गेट रेडी, सुबह 7 बजे तक क्लास होगा. हाँ, दिन रात को 1 बजे तक करते हैं ना क्लास. आई थिंक आफ्टर दिस वी विल हैव कपल ऑफ मोर सेशंस ऑन थर्सडे एंड फ्राइडे एंड देन विल रैप अप. Attended, okay. Okay. Don't worry, this class won't be interconnected to that class. In this class I'll be teaching you Dijkstra. Don't worry. And we'll be solving probably 3 or 4 problems on Dijkstra. DSU will be on next day. DSU I'll do tomorrow. DSU and problems on DSU will be done tomorrow. Okay. मॉर्निंग वाला जो पढ़ा है वो बाद में देख लेना. आई हैव डिसाइडेड आई विल नॉट डू द प्रॉब्लम दैट आई लेफ्ट फ्रॉम द मॉर्निंग फॉर नाउ. वी विल डू दैट प्रोबब्ली सम टाइम अदर टाइम. ठीक है. एलियन वाला करना था, बट आई सी अ लॉट ऑफ पीपल हु हैव जॉइंड न्यू नाउ, सो दे विल फील एलियन टू दैट प्रॉब्लम. एलियन, राइट? No, I don't. Do I seem tired? I look fresh, isn't it? Don't I look fresh? I look so fresh. This is the lecture 4. Please make sure you watch the previous lecture. Please watch. Please make sure you watch the previous lecture. अब मैं सही लगूंगा है कि नहीं? Lag? I don't think it's a lag. Is it lagging? Is it lagging? Lag हो रहा है. Now let me know if it is lagging. I think it should work now. I think it should work now. अभी देखो, अभी सही चल रहा है ना? Working now? Okay. अभी ठीक है ना? Perfect. Let's get started with the introduction before starting off. तो थोड़ा सा टाइम इंट्रोडक्शन को दे देते हैं. So yeah, for everyone who's new out here who does not know me, my name is Raj Vikramaditya. I am known as Striver in the programming community. I'm a competitive programmer. Currently, I'm working as a software engineer, where you can definitely Google that. You'll get to know. I'm a candidate master at Codeforce, as a 6-star at CodeChef. I've been teaching from the past couple of years. I do run a YouTube channel where I teach data structure algorithms, and I have around 1 lakh plus subscribers. The channel goes by the name TQ Forward. You can definitely check it out. And the subjects that I take are competitive programming, DS Algo, C++, interview preparation. And if you are willing to take any of the Unacademy subscription, you can definitely use the coupon code Striver in order to get 10% discount. Okay, and if you haven't checked out yet Relevel, please make sure you check. Bro, why don't we get notifications? अब एक ही चैनल पे 15 बंदे भर जाएंगे तो क्या ही नोटिफिकेशन मिलेगा. So don't expect notifications. या just keep a track. 10-15 बंदे हैं तो बाकी लोग को कोई देखता नहीं है, तो बेसिकली क्या होता है कि आपका जो नोटिफिकेशंस है वो जाते नहीं है दूसरे लोगों के. Because what happens is, see, if there are 7 videos from a channel in a day, and then you do not click on 6 videos, and then when my video comes up, no one clicks it, because वो recommend ही नहीं होगा. Simple as that. So Relevel by Unacademy. So many a times candidates miss out on great opportunities due to multiple reasons. ठीक है. If you're someone who is from a tier 3, or you do not have a good degree, or if you do not have a networking skills, then Relevel is something which you should definitely check out. It's a platform by Unacademy where your resume does not need a degree or anything in order to stand out. You just need to be having a talent, and you can apply to all the 50-60 companies that are on the platform. Now, what is Relevel? It's basically India's first test hiring platform by Unacademy, which is helping job seekers find their dream jobs. Now, what you just need to do is you need to go to Relevel, and you need to give their test. Okay, and you can apply for the test, and once you clear the test, you'll be getting a Relevel score. Using that, you can apply to all the 50 plus companies, which includes top startups like Cred, Razorpay, Urban Company, Code Nation, Yellow Messenger, etc., where you can apply. There are 1,000 plus job openings across business development, front-end development, back-end development, and yeah, everything gets sorted in 15 days from the, like, you get hired in 15 days, and you can book the slot according to your choice, and you can give the test, and after giving the test, you can create the video resume. And yeah, please make sure you check that out. And if you have not yet joined the Telegram group of this particular channel, you can join that. And if you are new to this channel, do consider subscribing. It's Unacademy competitive programming subscription has been discontinued. It will probably be back after some times. Wait for a couple of months, it will be back. As of now, I think it has been discontinued, hence you cannot take it. Probably there will be something else that might come up. So yeah, just wait for some time. Cool. I'll be getting started off with this particular thing. मैं इसको थोड़ा सा place कर देता हूँ सही से. ये क्या हो गया माउस को, पता नहीं क्या हो गया. रुको एक सेकंड, रुको, मेरा माउस को खराब. अच्छा, अब मैं समझा क्या नहीं हो रहा है. सॉरी माय बैड. अरे ये बहुत बड़ा पंगा होता है. तो अब सही है. Okay, so we have the screen. Lecture 3 is not uploaded on the channel. Lecture 3 will get uploaded. So guys, yeah, before getting started off, I did take a lecture 3 today in the morning at 11:30. Probably it has not been uploaded, or probably it is under processing. You can check that lecture under the graph playlist of this channel. Graph playlist under this channel, you will find that out. Okay, in the morning, in the lecture 3, what did we learn? We basically solved problems related to topo sort, this is what we learned. We learned the DFS addition and we learned the BFS addition, that is using the Khan's algo. Okay, and we also learned about the bipartite graph. So that is what I did in the morning, and we solved problems related to toposort. I was supposed to solve one more problem on toposort, but since there is a lot of audience which has not attended the lecture 3, probably in the last class, I'll expect you should have attended lecture 3. In the last class, I'll do that. Okay. Yeah, I'll do the alien problem in the last class because there's a lot of people who have not attended the lecture 3, so they will not understand toposort, right? So we'll discuss that on the last class once everyone has attended the other one. Okay, make sense? ठीक है ना? ठीक है ना? Clear है? No. अरे competitive programming subscription price showing 20,000 per month. अरे मत like इस आप ले नहीं पाओगे, आप खरीद 20,000 पे करो. It's this like you cannot buy that as of now. They'll probably start something new, and the subscription model, I'm not sure if that will be continued or not, but as of now you cannot take a subscription. अभी subscription discontinued है. ठीक है, it'll come up फटाफट आ जाएगा, don't worry. It'll come up in probably 15-20 days. थोड़ा सा wait करो, आ जाएगा सारा. Okay, so today what we will be doing, I will be telling you that I will be specifically talking about shortest paths. Okay, we will be deciding about shortest paths. So I'll be talking about 0-1 BFS. I'll be talking about Dijkstra. I'm not sure about the spelling, you can check that out. Probably using priority queue as well as using the set data structure. So after this we'll be solving 3 problems. That is what my plan will be for today. Okay, so let's get started guys. Everyone's ready? Lecture 3 में repeat क्यों करूँगा? Yeah, flood fill easy है. Please do flood fill yourself. It's very easy. It's a simple DFS. It's a simple DFS. You can do it easily yourself. Don't you think? Guys, everyone ready? शुरू करें? शुरू करते हैं? चलो. So 0-1 BFS. Let's first understand what is 0-1 BFS. Now assume I'm giving you a graph, something like this. Okay, and the edge weights, yes, I repeat, and the edge weights are among 0 and 1. Like the edge weights cannot be anything apart from 0 and 1. So assume this is 0, this is something like 1, this is 1, this is 1, and probably this is like 0. Okay, so if the edge weights are something like this, then you can definitely apply something like 0-1 BFS. If the graph contains edge weights which are 0 or 1, right, or just 1, like only these 2 numbers are the weights, not apart from that, then you can definitely apply something which is known as 0-1 BFS. Okay, and in order to do that, what you have to use is a DQ data structure. In order to do that, what you have to use is a DQ data structure. Okay, and remember, in the DQ data structure, we will be storing a pair. What will be the pair? The pair will be a node and a distance. The pair will be a node and a distance. ठीक है? Is the video clear to everyone? Clear ही तो है? ठीक है? The pair will be a node and a distance. So initially what you will do is you will take 1, 0, stating 1 is your starting point, and along with this what you can do is you can create a distance array. Let's create a distance array. So I've created a distance array, and in this distance array please make sure that this is 0 and everything else is an infinity. Everything else is an infinity, and you have a DQ. So this is the initial configuration. In the initial configuration, do have a DQ. What is a DQ data structure? It can be a list, it can be a DQ. So generally in a DQ or a list data structure, what happens is you're allowed to push from the front, you're allowed to push from the back. So both kind of allowances are there. You can push it from the front as well as you can push it from the back. Okay? And you will also have a distance array. In the distance array, the 0th guy will have something as a 0 and everyone else will have an infinity, 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 infinity. Make sense? एलियन डिक्शनरी का बता दो यार इनको. अरे बहुत लोग सुबह का लेक्चर नहीं अटेंड किए थे ना, बहुत लोग सुबह का लेक्चर नहीं अटेंड किए थे. ठीक है, तो अभी एलियन डिक्शनरी करेंगे तो दे विल नॉट अंडरस्टैंड. ओके, दैट्स व्हाई आई थॉट लेट्स स्टार्ट ऑफ ए न्यू टॉपिक सो दैट people don't find this alien. And once probably you'll get couple of days time, you can go through the alien dictionary problem, and you can go through the lecture 3. Once you will go through the lecture 3, and probably in the last day, Friday, at the later half, we will do the alien dictionary. Okay, make sense? सुबह भी class हुआ था. There was a lecture 3 that was in the morning that was taken. There's a lecture 3 in the morning that was taken. Over there I taught topo sort, which is very important, so please make sure you check it out. Okay, okay, so you'll be given a graph, and the weights will be in 0 and 1. Okay, basically the edges weights either will be 0 or will be 1, and you'll be given a distance array. And the distance array, initially the starting point, the starting point over here is 1, so 1 will be 0. The starting point over here is 1, so the starting point will be 1. Okay, and that will be marked as 0. Everyone else can be marked as an infinity. Yes, everyone else can be marked as an infinity. You can take a DQ. What is a DQ? Push front, push back. Okay, and in that what you will do is, whatever is the starting node, yes, whatever is the starting node, you'll take that and you'll say in that starting node the distance taken is 0. So that's how you will start off with. Okay, right after that, let's start the process. So what you will do is, you will say, okay, let's take this out. So this is the node, and I am taking a distance of 0. Yes, I'm taking a distance of 0. Where can 1 go? You'll be like, hey, listen, 1 can go to 2. Okay, so by the way, I'll tell you ki यहाँ पे what is the funda over here? Agenda, sorry, not funda. What's the agenda over here? The agenda is, you will be given a source node, and from source node to all other nodes, find the distance. Okay, from source node to all other nodes, you have to find the distance, find the shortest distance rather. Okay, that's the funda. Like if the source node is 1, from 1 to 2, which is the shortest distance? 0 is the shortest distance. From 1 to 3, which one is the shortest distance? This. From 1 to 4, which one is the shortest distance? This. So you just need to figure out which is the shortest distance from a particular node to other possible nodes. That is what you need to figure out. So initially whatever is there, you take it out and you say that these are the adjacent nodes. Okay, and now what you will say is, from 1 to 2 the distance taken is 0. So in order to reach 2, the distance taken will be 0, which is better than the previous distance that you took. Previously you took an infinity distance, so this distance is much better than an infinity distance. So what you'll do is, you'll take this distance 0, so and you'll push that. Remember, if the distance is 0, you'll push that into the front. If the distance is 0, you will push that into the front. Okay, now if this distance is also 0, so 3 will also become 0, and that's better than infinity. So again you'll push that into the front, so it will become 3, 0. Remember, if it's a 0, you push that into the front. Right after that, what happens is, you get something as 4, and in order to reach 4, the distance is 1. So for 4 you will get a distance which is 1. So if a distance is 1, what you'll do is, you'll push it into the back. Yes, you'll push it into the back, and it will become 4, 0. Done. So once you've done for this, you can say this is done. Now you can erase it. Okay, let's erase it. So you have erased it. Next, you get this guy and you say, in order to reach node 3, you require a distance 0. From 3, where can you reach? You can reach 1, you can reach 2, you can reach 4. Again, makes sense, because from 3 you can reach 1, 2 and 4. So that is all what I have written. So from 3 to 1, from 3 to 1, sorry, 3 to 1, it's a 0. From 3 to 2, it's a 1. From 3 to 4, it's a 1. So for reaching 1, the total distance is 0. So over here there's already 0, so there's no need to again take it. In order to reach 2, the total distance is 1, and I see that for reaching 2, the total distance is already 0, so we will not consider this. Similarly, in order to reach 4, the total distance is 1, so there's already 1, so you will not consider this. So in this order, yes, in this way, what you can do is, you can keep on trying. If next guy, then the next guy, and you can keep on trying. At the end of the day, whatever is the distance array having, you can say, okay, this is the shortest distance from the source node to all other nodes. Is this clear? 4-1 होगा ना, कहाँ 4-1 है? 4-1 होगा, सॉरी, तो किसी ने बोला चैट मत पढ़ो, तो मैं चैट नहीं पढ़ रहा था. 4-1 होगा. क्यों नहीं कर सकते? क्यों नहीं कर सकते? We need to understand. See, our intuition is let's understand the intuition, and then I'll take a bigger graph, then I'll explain you. Our intuition is compute the shortest distance at first. Compute the shortest distance at first. That's my intuition. So if in the DQ I push on the zeros on the front, push on the ones on that, so this portion will always contain the nodes which are reachable by 0 distance, and this portion will always contain the nodes which are reachable by a distance 1. That's the funda. I always want to take the shorter distance. ठीक है? नहीं, ये this is not extra. This is 0-1 BFS. This is 0-1 BFS. We don't use a priority queue. We're not using a priority queue. Instead of that, we're using a DQ data structure. Okay. Now, you might ask me, hey Striver, why do we require, yes, you might ask me, hey Striver, why do we require a DQ? Let's understand. Let's take an example, you'll understand. If I have a 1 over here, and assume I have a 2, assume I have a 3, assume I have a 4, and assume I have a 5, and then I have something like 5, 6. Okay. Now, just an example. Let's take an example where I say that, hey, this is 1, this is 0, and this is also 0, and this is 1, and this is 0, and this is 0. Now, if you do not, I repeat, if you do not take a DQ and you follow the standard queue, and if you follow the standard queue, so in queue, it's always like this, right? It's always like this. So if you follow the standard queue procedure, queue क्या होता था? First in, first out. Queue is first in, first out, and stack is last in, first out. Okay. So queue was first in, first out. So initially, if it have kept, like if I just take this distance array, let's understand why something like a queue data structure will take a longer time. I'm not saying it will not work. I'm saying it will take a longer time. Let's understand why. So if I take 1, if I take 2, if I take 3, if I take 4, if I take 5, if I take 6. Okay. So 1 is 0. So I'm saying 1 at 0. I'm saying 1 at 0. Okay. मैं क्या बोल रहा हूँ? मैं बोल रहा हूँ 1 at 0. Now over here I'm saying to reach node 1, I am taking a distance of 0. So where can 1 reach? I'll be like, hey, listen, 1 can probably reach to 2. So if these guys are infinity, if the distances are infinity, remember if the distance array is infinity, because when I start off, I know that from 1, in order to reach 2, I will take infinity distance. From 1, in order to reach 3, I'll take infinity, and then you have to figure out slowly and slowly what are the minimal distances. We have to figure out slowly and slowly what are the minimal distances. ठीक है? So अभी देखो क्या हो रहा है. From 1 to 2, that should be 1. So तुम बोलोगे कि in order to reach 2, the total distance will be 0 plus 1 equal to 1. In order to reach 2, the total distance will be 1. So you'll say, better, I've got someone better. So you will replace the distance. Now you'll push it over here, right? You'll push it over here saying 2 तक पहुंचने के लिए 1 लगा रे भाईजान. 2 तक पहुंचने के लिए 1 लगा. मैं बोलूंगा हाँ भाई सही है. Now 1 says in order to reach 4, yes, 1 says in order to reach 4, you will be requiring a distance of 0. So 4 will be 0. So 4 will be 0. Correct? Now you will say 4 comma 0. Perfect. So 1 का तो हो गया. Let's erase it. So 1 is done. So I'll erase it. 1 is done. I'll erase it. Next, I get this 2 comma 1. So I am saying in order to reach 2, I'll take a distance of 1. Now 2 says I can reach 1. So 2, 1 will be 1. In total 2. But I still have better, which is 0. I still have better, which is 0. So I will not be taken. I'll not be taking this. This will not be taken. And I'll say from 2 to 3 I will go. From 2 to 3 I will go. And from 2 to 3 what will be the distance? 1. So 3 will say I will take a distance of 2. Now don't you think if you would have taken this path beforehand, it would have been a better job. Now what is happening, तुम ये वाला पाथ ले रहे हो, फिर तुम ये लोगे, फिर ये जब आएगा फिर ये इसको वापस रिप्लेस करेगा. Don't you think that as of now you have taken 3, 2 saying that this path, let's consider this path, but don't you think logically it would have been better if you would have taken this path? Don't you think that's the logical intuition? Don't you think? Don't you think if you have taken the zero distance, it would have been much better? Tell me. Did you understand why taking this might not help you? Yes or no? Q approach is not wrong. I'm not saying Q approach is wrong. What will happen is the Q will end up taking a lot of time, because abhi kya hoga dekho, you will take 3 equal to 2, so 3 equal to 2 is gone, then you will be like erase it again, and after that you will take 4, 0, so 4, 0, from 4 you will be like, okay, we can reach 3, so that will be 0, so you will say 3 is now 0, so again you will insert 3, 0. So you are doing a lot of task, right? Abhi dekho 3, 0 gaya, but in the next instance you will get 3, 2. But do I need to do 3, 2? Because we already have 3, 0. 3 tak better distance pe we can reach in a better distance to 3. So why will I take this? क्योंकि फिर ये इधर जाएगा 2 बोलेगा, फिर ये इधर जाएगा 2 बोलेगा. So it's a repetitive, it's more number of operations that I'm doing. It's more number of operations you are doing. Don't you think greedily it's better if we take the smaller distance guy at first? That will reduce the number of operations. Has everyone understood this? Can I get a UQ? Can I get a UQ? Can I get a UQ? Everyone is perfectly understood that what's the problem in taking a Q data structure. See, I'm not saying it will not work. What I'm meaning to say is it will work, but it's going to take a lot of time, because you will do repetitive calculations. For 3 you did a calculation for 2, and the next time 3 of 0 will come, and again you will do the calculation. So it will be repetitive. So you can use priority queue. I'm not saying you cannot use priority queue. See, you can use a priority queue which will always give you the shortest distance. That's pretty obvious. It'll always give you the shortest distance. But the funda over here is if you use priority queue, there will be a log-n factor introduced. If you use a priority queue, there will be a log-n factor introduced. That's why we will make sure that we take a 0-1 BFS. Why does 0-1 BFS works? Let's understand. Why does 0-1 BFS works? अभी एक चीज बताओ, लॉजिकल एक चीज बताओ. Initially, there is only one guy. That's a source, 0. Okay. So 0 guy, the distance 0 is already at the front. If you add 1 to it, and probably this is node x with distance 1, right? And x, 1 comes out. And again you add 1, and probably you get y, 2. That's okay. And assume, so this came out. So y, 2. Now on y, 2, probably you added 0. The distance added is 0. So you will end up pushing it right at the front, not at the back. So क्या होगा देखो, ऐसे होगा 0. After that a set of 1s will come. After that a set of 2s. After that a set of 3s. After that a set of 4s. Let's understand by taking a wonderful example. एक अच्छा सा example लेते हैं. This will get completely clear. Let's take a wonderful example. You'll get this completely clear. So I've taken this particular example, okay? थोड़ा सा बड़ा, मतलब बहुत ज़्यादा बड़ा मैंने ड्रॉ कर दिया, मुझे फिर समझाने में दिक्कत हो, थोड़ा छोटा कर देते हैं. Okay, so I've kept it like this, okay? और प्रॉब्ली थोड़ा सा बेटर कर सकते हैं, इसको 0, इसको 1 1 0 1 0, yeah, well, probably we can do something like this. Yes, probably we can do something like this. That looks good. Now what I will do is, और probably थोड़ा सा अगर बेटर भी, रुको थोड़ा सा बेटर करते हैं इसको. Yeah, I think this should, this will work fine. So what I'll do is I'll take a DQ. Okay, I'll take a DQ. Let's take a DQ. So in this DQ, I'll say this is the source node. Okay, and I'll keep a distance array. I'll keep a distance array. Okay, and in this distance array, I'll say this is 0 and everyone else is infinity. So you've understood the intuition. Yes, we have understood the intuition. Now what I'll say is 1 comma 0 is initially I have 1 comma 0. Let's take this out. So let's take this out. So I'm saying in order to reach 1, I'm requiring a distance 0. 1 says 2 जा सकता हूँ, 3 जा सकता हूँ. 2 को जाने के लिए 0 लगेगा, 3 को जाने के लिए 1 लगेगा. So 2 will require a 0, 3 will require a 1. So logically, which one should be the first one to be executed in the next iteration? 2 comma 0. So thereby you insert 2 comma 0 at the front and 3 comma 1 at the back, because at the next iteration when you come back you will get 2 comma 0. 0 ही तो पहले तो छोटे डिस्टेंस को ही काम करना था. We had to take the smallest distance at first. So I've taken the smallest distance at first. Now 2 can reach 1, 2 can reach 4, 2 can reach 3. Now let's see. If it takes a distance 0, that's 0. Not to be taken, because in order to reach 1, there's already a distance of 0. In order to reach 4, the distance is 1, which is 1. So I'll say 4, 1. 1 है, पीछे जाएगा. Perfect. From 2 to 3, it's 1. Again 1. 3 is already reachable by 1. So no need to take it. 3 is already reachable by 1. So no need to take it. So you're done with this. Next I'll take 3 comma 1. So now 3 can go to 2, can go to 1 and can go to 5. Let's see. If it goes to 1, it will take 2, which is again not considered, because 1 में मैं पहले 0 पे पहुंच सकता हूं. I can reach 1, मैं बहुत easily 1 में पहुंच सकता हूं. From 3 to 2, it will be again 2. In 2, I can reach at 0 distance, not to be taken. From 3 to 5, I'll be taking a distance of 2. 5 infinity 2. बताओ कहां पुश करेंगे? पीछे या आगे? 5 comma 2, where will it be pushed? 5 comma 2. Do you see that the increasing distance is happening? Because whenever you're doing a +1, you're pushing it on to the back. When you're doing a +0, आगे से ही करो, क्योंकि डिस्टेंस तो बराबर है भाई. डिस्टेंस तो बराबर है, तो आगे से करके are you maintaining the order? Got it? Have you understood this? Are you maintaining the order? So what will happen is, initially you will start off with zeros, then whenever you push the distance +1, 1's distance will come. Then whenever you take out 1 and you add a +1, then 2's distance will come at the back. Then whenever you take 2 out and you add +1, 3's distance will come. So automatically something like a DQ maintains your increasing order. You don't have to use a priority queue. Hence, the log-n factor of priority queue can be eliminated. Got it? Has everyone understood this? UQ, please. UQ, please. If everyone has understood, why are you pushing at the back? UQ, right? Okay, perfect. Aniket has understood. Very simple enough. Got it, everyone? Okay, perfect. 5,2 आया ना, इसीलिए तो पुश किए पीछे. अब 4,1 से जब तुम 4,1 पे 6,1 आएगा ना, तो 6,1 को आगे करोगे. देखो, अब थोड़ा सा और एक स्टेप आगे जाके समझ जाओगे शायद, जिनको नहीं है. नेक्स्ट स्टेप क्या है? 4,1. In order to reach 4, I'm taking 1, right? अब 4 से कहां जा सकते हैं? 6 फॉर एन एग्जाम्पल. 6 का भी 1 आया. 6 का जब 1 आया ना, 1 आया है, पीछे नहीं करेंगे. तुम 0 ऐड किए हो, मतलब डिस्टेंस बराबर है अभी भी. अगर डिस्टेंस बराबर है, आगे ही कर दो. तो देखो अभी भी 1 और 2 डिस्टेंस इज मेंटेन इन अ सॉर्टेड ऑर्डर, राइट? Distance is still maintained in a sorted order. Whenever you add up 0, push in front. Whenever you add +1, push at back. Simple. +1 से distance will increase, so increase 1 will go back. +0 से distance will still stay same, so come front. Like 6,1, 4,1 से तो बराबर था, 4,1 से तो बराबर था, इसलिए तुम आगे से पुश किए 6,1. Got it? Okay, you to everyone. Everyone understood this? EQ means understood. I call it EQ. Okay, everyone EQ, right? Understood question होता है, but EQ बन गया उस EQ, right? Okay, cool. So everyone is understood. Okay, so ये sublime कहाँ चला गया मेरा? रुको एक second. Sublime. ये मेरा क्या हो गया? ये लापी क्यों नहीं काम कर रहा? ये सब्लाइम काम नहीं कर रहा भाई, ये तो हद हो गया. सब्लाइम क्यों नहीं काम कर रहा भाई? ओहो, डाउनलोड अपडेट का ऑप्शन आया था. नहीं करेंगे अपडेट, नहीं मने मेरे को करने का. सही. Okay, let's write the 01 BFS. So I'm calling it as BFS of 01. So what I'll do is, you always take a DQ. Okay, you always take a DQ with a pair, and assume the source node is given to you. Assume the source node is given to you. So probably you can also create a vector of distance of n comma 0, and then probably you can just iterate and make sure everything is infinity, assuming to be infinity to be 118 or 189 or something like that, int max for that reason. Okay, that's what I've taken, infinity int max. अभी मुझे पता है कि distance of source is 0, right? That's something which I know, and I know in the DQ अभी कोई नहीं है, तो push front करो back करो एक ही बात है. So source comma 0, right? Now what will I do? I know I'll have to go on till the DQ is non-empty, similar to BFS, and I'll say the node is DQ dot front and the distance is DQ dot front dot second, and I can do a DQ dot pop. Okay, now what I'll do is, I will say, okay, I have to go to the adjacent nodes, so let's go to the adjacent nodes. That's how you'll go to the adjacent nodes. And can I say, currently I am at node. Yes, currently I'm at node, and the distance that I have taken to reach node is distance. The distance I have taken to reach node is distance, right? Plus what? Plus the edge weight. Now remember this. If you remember, we stored in pairs. If it was a weighted graph, we stored in pairs. Do you remember? So the adjacent node over here will be it dot first, and the weight will be it dot second. So what I can say is, distance plus WT is lesser than this of where are you reaching, the adjacent node. If that's the case, yes, if that's the case, you will say, okay, that's perfect. So I will say this of adjacent node will be equal to, yes, will be equal to distance plus WT, and if the weight of the edge is 1, I will say DQ dot push back, and I'll push the new node, which is adjacent node, and the distance plus WT. That is what I'll push. And at the same time, if it is not, I will do a DQ dot push front of the same thing. Does that make sense to everyone? Once I've done this, I can say I will just iterate from this to this, and I can say the distance is easily distance of I, and that will make sure that all the distances are printed. क्लियर है? इज इट क्लियर? डीक्यू मैंने क्यों लिख दिया क्या गलती से? डीक्यू तो लिखा है। हाँ स्पेलिंग, मेरे स्पेलिंग भूल जाओ, छोड़ो, मुझे मेरा स्पेलिंग बहुत खराब है। हाँ ठीक है, क्रिस्टल क्लियर? समवन सेड इफ कंडीशन में ग्रेटर देन इक्वल टू 1 आएगा भीड़ू, भीड़ू आएगा भैया। अच्छा नहीं नहीं नहीं, सही है, सही है। इफ पहले का डिस्टेंस प्लस अभी का डिस्टेंस मिलके छोटा होता है तो ही ना रिप्लेस करेंगे। 375 through 3. No, if this, it has to go inside that, right? It has to go inside that. If 373 is not executed, then it will not work, right? If 373 is not executed, it will not work, right? Yes, this is only applicable for two different weights, which are 0 and 1. Like it can be anything, but hypothetically, it should be two different weights. It cannot be multiple weights. Just because it is two different weights, you know, by addition of one, like it has to be something has to be 0. The other one can be 5, can be 10. Like one has to be 0, because when you add that guy, when you add 0, the weight still stays the same. The distance still stays the same. That's why I push it on the front. The other one can be 1, can be 5, can be anything, but it has to be constant. There has to be two weights. One has to be 0. 0 तो sure है. 1 के जगह 5 भी हो सकता है, 10 भी हो सकता है. Okay. Time complexity will be go of n plus e. N plus e because number of nodes plus number of edges. अरे लीड कोड क्वेश्चन कराओ. डेक्स्ट्रा पता नहीं है, डेक्स्ट्रा क्वेश्चन खोलूंगा तो कहां से पता चलेगा? पढ़ाने दो यार, पढ़ाने दो, फिर ना डेक्स्ट्रा करेंगे. सुबह भी कराया था. पॉप फ्रंट क्या हो गया? पॉप फ्रंट, हाँ पॉप फ्रंट, सॉरी, या पॉप फ्रंट. ओके, एट 375 वेट ग्रेटर देन इक्वल टू 375. अरे नहीं भाई, वेट 1 ही, मतलब ये 0 1. आई एम अज्यूमिंग दिस इज 0 1. आई एम अज्यूमिंग दिस इज 0 1. वेट हैज टू बी कांस्टेंट. Yes, you have to have two weights. In short, you have to have two weights. It will only work for two weights, where the first weight has to be 0. The second weight can be x plus x. The second weight has to be x. Okay. Now tell me, what is the intuition that we did see over here? Why did we not use a Q? Why did we not use a Q? First tell me that. Why did we not use a Q? सब मेरे को बताना पहले आंसर. सब मेरे को आंसर बताओ चैट में. Why did we not has to be 0? क्योंकि देखो, अगर 0 नहीं ऐड करोगे, अभी बताओ, जब तुम इस साइड से ऐड कर रहे थे, क्यों ऐड कर रहे थे? क्योंकि डिस्टेंस बराबर था. डिस्टेंस बराबर था. अगर 0 को छोड़ के कुछ होगा तो डिस्टेंस तो बराबर होगा नहीं ना. तो तुम आगे कैसे ऐड कर सकते हो? तुम्हें क्या मेंटेन करना था? तुम्हें एक सॉर्टेड फैशन मेंटेन करना था, राइट? तो तुमको पता है जब 0 ऐड करोगे वही डिस्टेंस आएगा, तो भाई आगे ही भेज देना. ओ बैटरी खत्म. ओ हो. Okay, looks like the camera's gone. Okay, it's back. Okay. Yes. So everyone has understood? No. You have to have 0. See, 0 जरूरी है, क्योंकि तुम 0 अगर ऐड करते हो तो पहले का जो डिस्टेंस निकला था, 0 ऐड करने पे वही डिस्टेंस रहेगा. इसलिए तुम आगे ऐड कर ले रहे हो. समझो चीज को, इसलिए तुम आगे ऐड कर पा रहे हो. एंड जब तुम डिस्टेंस +1 या कुछ भी बढ़ाते हो तो डिस्टेंस बढ़ गया है, बढ़ गया है, इसलिए तुम पीछे ऐड कर रहे हो क्योंकि वो बढ़ गया है, तो तुम्हें सॉर्टेड मेंटेन करना था ना, इसीलिए. गॉट इट? So everyone has understood why not Q and why a DQ? Because Q is something which will do multiple computations. You will reach a node multiple times with different distances. Okay. Now what if I just make this question to something else? Change two weights to multiple weights. Then what will be the question changing to? Change two weights to multiple weights. अरे यार ये क्या पंगा है यार, ये चल क्यों नहीं रहा? रुको एक सेकंड रुको. ओ चल जा भाई, चल जा. रुको, क्या प्रॉब्लम है आज आईपैड को? आज के ही दिन सारा पंगा होना है इसको. वेट करो. Okay, so can you tell me, चार्ज हो जा भाई, चार्ज हो जा, कुछ होना हो चार्ज हो जा. So can you tell me what will you use if there's multiple weights? Can you tell me what will you use if there are multiple weights? Yes, if there are multiple weights, and what do you want? You want it in the sorted order. You want the sorted order, like the distances to be in sorted order. So what will you use instead of a queue? So that you always get the shortest distance at first. You always follow the greedy technique. Yes, priority queue. Or you can use also set data structure. That's okay. Okay, so we're going to use a priority queue. Yes, we're going to use a priority queue. Let me just show you an example. Let's take a very easy one. Okay, let's see this. And yeah, let's get started with this. So initially, if you have source is one, source can be anything. Okay, infinity, and take a priority queue. Yes, take a priority queue. In this priority queue, distance comma node. In this priority queue, distance comma node. So distance of 0, node 1. Where can 1 go? 1 can go to 2, which will take a distance of 6. 1 can go to 3, which will take a distance of 1. So in order to reach 2, the distance will be 6. In order to reach 3, the distance will be 1. So you will insert, you will say 2, your distance is 6. 3, your distance is 1. So 1 comma 3, 6 comma 2. Inserted. Once you've inserted this, you can erase this. Yes, you can erase this. Now tell me one thing, guys. A very easy question to you. Very easy question to you. Priority queue will give what? Like if you take 6 comma 2, if you take 6 comma 2 and you do it, there'll be repetitive calculations. There's absolutely no need to go via this path because this is huge. This is large. There's no need to consider this path only. So priority queue will say, hey, listen, the next guy after 0 comma 1, like the shortest distance is 1 comma 3. So I'll say 1, 3, and 3 will say I can go to 1, but then I'll take a distance of 1 and total will be 2, and 1 can be reached in 0, not to be considered. 3 can go 4, which will take 2, 3. So 4 will say I'll take a distance of 3. So I'll say 3 comma 4 is there. Perfect. So this is also done. Next 3 comma 4 or 6 comma 2? 3 comma 4. Distance of 3 in order to reach 4. Now 4 will say, hey listen, I can go to 3, which will take me a distance of 2, hence a total distance of 5, not to be considered. 4 can say I can reach 2, which will take me a distance of 1, which is a total distance of 4. So in order to reach 2, I can still go in a better distance of 4. So I'll have a better distance of 4. So this time I'll put 4 comma 2. Perfect. Next time the priority queue will give 4 comma 2. 4 comma 2. Now 2 can go 1, can go 4, but both of them will not be considered, and the next time will come 6 comma 2, that will not be considered. So once you've done the entire iteration, your distance array, yes, once you've done the entire iteration, your distance array contains the shortest distance from the source to every other node. From 1 to 2, it's 4. Why? This path. Understood how priority queue helped you minimize operations? How priority queue helped you minimize operations? Had you not used the priority queue, then you'd have taken 2 comma 6, then from here you'd have gone here, then so on. Got it? It would have taken a lot of other operations. Understood? Is this understandable? Clear to everyone? Clear to everyone? UQ, right? Okay, perfect. Perfect. Everyone's saying UQ. Perfect. Clear? Okay. So logically, did you understand how did you can use map? How will you use map? How will map give you the shortest distance? So as of now, let's implement this using priority queue. Then I'll tell you the set wala funda. Okay. Let us set wala funda also. Set is also easy. Okay. So how will the code change? If I just copy paste this, and I write this, can you tell me how will the code change if I write this as try extra? क्या changes होगा? Over here we'll have a priority queue. Priority queue is done. Distance will be same. Source will be 0, and this will be PQ. Push. This will be top. This will be top. This will be pop. Same. Exactly same. Now over here, there will be no comparisons now. Over here, there will be no comparisons, and you can simply say, hey, PQ dot push. I think we just do these many changes, your code will work. Don't you think that if you do these many changes, your code will work? Got it? Okay, so complexity for this. What's the complexity for this? Can you just analyze the complexity for this? The complexity क्या होगी? Zero source. Oh. So thank you. Yeah, always zero source. The complexity for this. Yeah, first distance, then node. vloggy. N log n in order to be generic. The complexity will be n log n because you're iterating across everyone. Like it will be n log n, you can say n plus e, because for every time you're doing it. So yeah, if you summarize this, it's n log n. Why e is for the number of edges that you are iterating on. E is for the number of edges that you're iterating on. Okay, is for the number of edges that you're iterating on. Line 408 और भी कुछ छोड़ दिए? हाँ ठीक है, अरे इतना तो खुद कर लो. Okay, so we have understood this. Now I ask you, we can also do this using set से खुद कर लेना. It's easy. If you use set also, you can do it. Okay, you can do it using set, not a big deal. Now I ask you, let's do one question. Okay, let's do one question, which is directly taken from Code Forces. Okay, this is the question. I want you to read the question. It goes by the name 20C. 20C. Please read the question and tell me how you do this. Did not understand vloggy. मतलब vloggy in the sense, देखो, n number of nodes, and in a priority queue it takes log n. That's why log n, like n log n plus e for the edges that you are iterating on. Got it, Upmanyu? Okay, please go through the question. Link array. Okay, okay. So let me explain you the question. Let me explain you the question if you cannot read it. If you cannot read it, I'll explain the question. So, by the way, just I forgot to tell you one thing. Dijkstra will not work for negative cycles. Dijkstra will not work for क्या हो गया? कहाँ लिखा था भाई? एक सेकंड रुको. Let me find out किधर लिखा हुआ था. Yeah. Cool. So let me tell you one thing. Dijkstra does not works for negative cycles. For negative cycles, Dijkstra will not work. Why? Logically, imagine if you have something like this. 2 minus 1 minus 10 and a 5. What's the shortest distance between 1 to 5? What is the shortest distance between 1 to 5? Can you tell me what is the shortest distance between 1 to 5? A Bellman Ford also cannot do it. Logical, it's incorrect. Logical, it's incorrect. Can you tell me what's the shortest distance between 1 to 5? बोल सकते हो क्या होगा shortest distance between 1 to 5? The shortest distance. ये भी like भैया इधर से जाएंगे, ये जाएंगे, ये जाएंगे, ये जाएंगे, फिर जाएंगे, फिर जाएंगे, फिर जाएंगे, फिर जाएंगे, फिर जाएंगे, फिर जाएंगे. Infinite. Because the more you take turns, the distance reduces. The distance reduces. The more you take turns, the distance reduces. So you'll be like, Bhaiya, go, 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 go. And the distance gets reduced every other time. The distance gets reduced every other time. Understood? For cycle, you cannot apply Dijkstra, or you actually cannot find shortest distance. It's practically impossible to find the shortest distance if there is a negative cycle, because logically it doesn't make sense. And this problem cannot be solved because in which earth do you while traveling someone reduces distance? Doesn't happens anywhere. Or someone gives you a lot of like infinite awards, that also doesn't happens. That's why this method is not allowed. That means for negative cycles, Dijkstra will not work. Clear? It's practically not possible. Clear है सबको why Dijkstra does not works? Clear to? Okay. Let's understand the question that I gave you from Code Forces. Now Code Forces tells you, everyone knows that you know Dijkstra's algorithm. Yes, Dijkstra is very simple. You can find out the distances. What if I tell you the source node is 1 always, the source node is always 1, and you know the ending node is always n. Over here n is 5. I want you to tell me what is the shortest distance from 1 to 5. You'll be like 1, 4, 3, 5 is the shortest distance, like shortest path. They're asking you to print the path. They're asking you to print the path. So can you tell me how will you do this? Yes, in order to figure out if there is a negative edge, you can use, yes, you can use something which is known as BF, which is Bellman Ford algorithm. Last day padhaunga, which is known as Bellman Ford algorithm, will tell you if there exists a negative or not. Yes, will tell you if there exists a negative cycle or not. Bellman Ford will tell you. Okay, so DFS? No, obviously not a DFS. Obviously not a DFS. How will you do any other idea? How will you do any other idea? Yes, yes, Karthik. Yes, yes, Karthik. Karthik Singh Kushwaha. Yes, Karthik. We can make a parent vector. Yeah, makes sense. How many of you cannot do this problem? BFS, no. Dijkstra, yeah, Dijkstra. Shortest path. Figure out shortest path. Whenever there is a shortest path and edge weights, you should always think of Dijkstra now. You are grown up. They just store the parent. Yeah. So for everyone, like, how many of you cannot do this? How many of you cannot do this? For people who can do this, can you write yes? How many of you cannot do this? Can you write no? Yes if you can, no if you cannot. No, print notes while popping from PQ will not make sense. How many of you can is yes, cannot is no. Okay. Jeta Jong can do, no. Siddharth cannot. Okay. No, okay. See, if you don't write no, I'll not solve. Okay, looks like a lot of people cannot solve it. Not an issue. I'll solve that for you. So for everyone who can solve this problem, I will give you the next problem that you can probably go and think. The next problem is maze 2. The problem is known as maze 2. Go and solve that out. Maze 2. If you don't find it over here, you will find it at lint code. Lint code. LINTCOD. Okay. Maze 2. Okay. Cool. Let's understand. So what you will do is, you will say, okay, I'm going to create a distance array. That's correct. ये कौन सा कलर आ गया भाई? ओहो. I'll create a distance array. I'll be like, okay, 1, 2, 3, 4, 5. And at the same time, I will create a parent array. Okay, right at the top. And I will be having 0, infinite, 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 and infinite. And I will say, one's parent is 1 itself, and everyone else as of now is -1, -1, -1. So this is the parent array, whereas this is the distance array. Okay. Next, take a priority queue and initially store distance comma source. Okay, initially store distance comma source. So what you will do is, yes, what you will do is, you will just be very smart in order to solve this problem. 1 second. Okay, so what you'll do is, you'll take the first guy out, 0, 1. Where can 1 go? 1 can go to 2, 1 can go to 4. So if he decides to go to 2, it will take a distance of 2. In total, it will take 2. So 2 says, I will take a distance of 2. So you'll say 2 takes 2. And from where does 2 come? From where does 2 come? 2 come from 1. So you'll say 2 came from 1. Perfect. Next, 1 to 4 is 1. So 1 comma 4. So 4 will be updated with 1. From where does 4 come? 4 comes from 1. Perfect. Next, you take 1 comma 4. Priority queue. From 4, where can you go? You can go to 1. You can go to 3. Okay. So if you, from 4, if you decide to go to 1, the distance taken will be 1. Hence a total distance of 2, which is definitely not better. Because 1 can be reached at a 0. So that's definitely not better. From 1 to 3, that's in total 4. So 3 says I'll take 4. And 3 came from 4. And 3 came from 4. So you can store that over there. This is also done. Let's take some other color. Otherwise, thoda panga ho raha hai. 2 comma 2. 2, 2. From 2, where can you go? You can go to 1, which is not being taken. You can go to 3, which is 6. 3 is already 4, not being taken. From 2, you can go to 5, which is 7. So 5 says I am 7. 7 comma 5. And 5 says I came from 2. Perfect. Store. Next. 4, 3. 3 says I can go to 2, I can go to 4, I can go to 5. Not to be considered, not to be considered. If you add up distances from 3 to 2, that will be around, I think, 4, which will give you 8, not to be considered. 3 to 4 will give you 3, which is 7, not to be considered. 3 to 5 is 1, 5. From 3 to 5, it's 5. So update the parent to be 3. Update the parent to be 3. So 3 is also done. And you can just keep on, if you can just keep on doing this. Once you have done this entirely, yes, once you have done this entirely, can I say this? Can I say that? Can I say that? At the end of the day, this is the distance array and this is the parent array. So let's backtrack. I know I have to start from 5. From where does 5 come? From 3. Where does 3 come? From 4. Where does 4 come? From 1. The moment you reach 1, that's your answer. That's your path. Reverse it. अब सबको आता है? अब सबको आता है? अब सब, हाँ इधर 1 होना चाहिए था, सॉरी इधर 1 होना चाहिए था, एक्सट्रीमली सॉरी, कहीं कहीं वो पंगा हो गया, मतलब ऊपर नीचे हो गया होगा, मतलब कहीं ऊपर नीचे तो हो गया, मैं 3 का अपडेट करना भूल गया, बट ठीक है, समझ में आ गया ना, अंडरस्टूड ना, मतलब कहीं ऊपर नीचे हो गया होगा. नो 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 डेक्स्टर, it isn't printing the same. It is not printing the node while you're popping up from PQ. It is not the same. In that case, you would have also printed 2 because 2 also came in. Na? There was a portion when 2 also came in. So how will you do this? So you just need to understand who updated distance. Who updated distance? That means he came from there. That's it. This is not DSU. This is just backtracking. This is just backtracking. Is it clear to everyone? UQ, please. UQ, if you understood. I just stored from where did I come and then I just backtracked. UQ. The stream को like कर दो यार. ठेंगा. Everyone's understanding? Perfect. Yeah, flood washel will be done in the last day. Flood washel will be done in the last day. So remember guys, if you like, this is a live class, you can ask doubts, that's okay. But for revision purpose, if you want it to be done in very quick, you can watch the Take You Forward playlist on Graph. Over there, it's recorded crisp, very crisp content. You can do it very fast. You'll get organized code, C++, Java as well. Okay. और तो प्रॉब्लम्स नहीं मिलेंगे, प्रॉब्लम्स इधर से कर लेना, ठीक है. चलो, जैसे दिस प्रिंटिंग पाथ हैज नॉट बीन टॉट ओवर देयर, सो प्रिंटिंग पाथ इज डन, राइट. सो इफ आई जस्ट कोड दिस अप, व्हाट आर द चेंजेस दैट आई नीड टू मेक? कैन यू टेल मी व्हाट आर द चेंजेस दैट आई नीड टू मेक, लाइक इफ आई हैव टू प्रिंट पाथ्स? Probably if I can keep a parent array, parent 0 equal to 0, like assuming it is from 0, assuming it is from 0th index. So over here you just need to make sure parent of, like just it or adjacent node will be the node, that's it. And after this, if you need to print the path, you just need to print the path while parent of n is not equal to 1, like parent of n is not equal to n itself, like, or 1 you can call it. Okay, like this is the opposite path, and थोड़ा backtrack करोगे तो print हो जाएगा. Like if you just print of n, and after that you can say, or you can be like int x is equal to n, and then you can just print of x. ये उल्टा पाथ प्रिंट होगा. This will be the opposite path that will be printed, by the way guys. This will be the opposite path that will be printed. So yeah, if you want to print the correct path, you just store it and reverse. Store it and reverse. Sir, please answer this. This is ये DSU नहीं है यार. ये मतलब कब मैंने बोला DSU है? मैंने कब बोला DSU है? that you are considering that this is DSU? Did I say that this is DSU? Nahi na. Did I say this is DSU? No na. Okay, cool. Clear hai? Okay, so everyone has understood this. Perfect. So everyone knows the extra, everyone knows 01 BFS, everyone knows how to print the path. Correct? Is this clear to everyone? ग्राफ के L3 आज ही सुबह पढ़ा है, सुबह 11:30 बजे। DSU is disjoint set union, disjoint set union होता है DSU। इनफाइनाइट लूप फंसेगा 451 में। नहीं मतलब इनफाइनाइट लूप क्यों पहुंचेगा? मतलब यहाँ पे 0 है बोल के बोल रहे हो क्या? मतलब if I take this as one based indexing तो फिर नहीं फंसेगा। मतलब one based indexing if I take it won't, right? If I take one based indexing everywhere then it will be okay. If I take one based indexing it will be okay, right? Yeah, you can take one based indexing, then it's going to be okay. कल क्यों नहीं आया बता दो था टेलीग्राम ग्रुप पे। लास्ट वाइल लूप एक्सप्लेन। इट्स इजी मैन। एक का बंदे का पेरेंट है, एक का प्रिंट किया, इसके पेरेंट पे गया, पेरेंट पे आया, इसका पेरेंट लिया, इसके पेरेंट पे, इसके पेरेंट पे लिया, इसके आया, इसके पेरेंट पे लिया, चलता गया पीछे पीछे पीछे। गॉट इट? गॉट इट धनंजय? गॉट इट? ये क्या हो गया? एक्सिक्यूट नहीं, सही है सही है। सही तो है। अरे ठीक है, अच्छा एक्स एक्स टाइपो टाइपो, अरे टाइपो, अरे टाइपो टाइपो, इट्स अ टाइपो। टाइपो में चढ़ जाते हो आप लोग तो। Okay, let's do one more question that's known as the MAT maze 2. Okay, again a common extra problem. So you can read the problem once. Probably maze 2 देखो तो ये हो रहा है क्या? अब ये गूगल कर पा रहे हो? मतलब is it logged? Is it logged? Is it logged? Lean code, then lean code. Read on lean code. It's a premium on lean code, huh? Lean code. Make lean code, guys, lean code. I'll not solve on lean code, I'll solve on lean code, you solve on lean code. So read this question, okay? Read this question, then I'll tell you, ठीक है? तब तक मैं इसका डायग्राम बना लेता हूँ समझाने के लिए। लोग क्वेश्चन पढ़ लो, तब तक मैं डायग्राम बना देता हूँ, ठीक है? The moment you understand question, you can write a UQ, right? The moment you understand the question, please write a UQ. Okay, have you understood the question? Have you understand the question? I mean, if you did get the question, maze 2. Okay, no UQ. Okay. Please explain the question. Okay, I'll explain the question. I mean, if you did get the question. Please explain the question. Okay, I'll explain the question, but how many of you did get it? Okay, Yuki. Okay. So let me tell you the question. So basically the question says there is a ball. Okay. So assume the ball was here, and if you say that it takes a left turn. If you say it takes a left turn, so left means ball will go and stop here. You cannot say by taking a left turn the ball will stop here or here or here. It will go and stop right on the boundary or right on the one. Like if you say it go down, it will go and stop here. For example, if you say the ball from here go down, it will stop here. From here go left, it will stop here. From here go right, it will stop here. Okay. For example, if you have a ball here and you say go right, it will stop here. So it will either stop right before one, or it will either stop somewhere at the boundary. Clear? Oh, screen change. I'll again explain. यार ये मैं फिर भूल गया screen change करना. Sorry. हाँ ठीक है समझ गया. Sorry, my bad. Okay. So if you're at the start, you can go left, so it will go left. Okay. If you're at this position, if you go down, it will go down and stop here. You cannot stop in between. If it falls, the ball will roll and end up right before one. Similarly, if you are here and if you say down, the ball will not stop here. The ball will stop here. If you say right, it will stop here. If you say left, it will stop here. Got it? For an example, if the ball is here and if you say to take right, it will go and stop here. Not here or not here. Right before one or right at the edge. Or right before one. Got it? So पहले ये समझ में आया क्या बॉल का रोलिंग कैसा होता है. Whenever there is a ball, if you roll it, it will stop at the boundary or right before one or stop at the boundary. If you roll it in any direction, it will roll and stop on the boundary or right before one. Clear हुआ ये चीज? बॉल का रोलिंग क्लियर हुआ? Is the ball rolling clear? Is the ball rolling clear to everyone? Ball rolling clear? How does it roll? The screen तो visible है भाई. So for an example, so they're asking you from start, how can you reach end? So there can be multiple ways. Yes, there can be multiple ways. One of the possible ways is you say it to go here, then you call it here, then you say go 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 here. How many steps will it take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 steps. 12 steps it took. And they want you to tell the minimum steps that you will take in order to reach from the start till the end. Ideally, you could have done this, but this is not allowed because it's a ball. If you start here and you go here, you have to reach here because it's a ball. Clear है question? The question clear है? अब तो clear है ना question? Is the question clear now? The question clear now? The question is, in the maze 2 question, it was like पहुंच सकते हो क्या? So you have to figure out the minimal distance. In the question maze 1 that we did the other day, we had to figure out can we reach? We have to figure out can we? Over here, if you can figure out the shortest distance, you have to figure out the shortest distance. Clear हो गया? Okay. How will you do this? Any ideas how will you do this? Any ideas how will you do this? Can we use a Dijkstra? Yes. Can we use a Dijkstra? I think we can. So can I say every cell, imagine this as a graph. So can I say every cell is a node? Something like this. Every cell is a node. And if you imagine every cell as a node, can you say, like, if you're over here and if you go left, you'll end up going here. So the distance is like 1, 2, 3. The distance is 3. Rolling across distance is 3. Right? From here, if you go here, the distance is 1, 2, 3. So node to node. Can I consider this as a node and this as a node? And the distance between them is 3. So can I think this is a graph question? Can I think this is a graph question? आरसीबी मैच हार गया, कुछ नहीं हो पाएगा ये आरसीबी का, कुछ नहीं हो पाएगा इनका, हारा भी एक इनसे, पक पक बेकार टीम. So, can we do this using 0-1 BFS? That's the first question. I think we cannot. We cannot. Why? Because there is nothing like a zero distance over here. We need to realize there is nothing like a zero distance over here. If we are moving, it might be 1 distance, it might be a 2 distance, it might be a 3 distance. So there might be a variety of distance. So 0-1 BFS is ruled out. So hence, what do we need to use? What do we need to use? We need to use something which is known as Dijkstra. Yes, we need to use something which is a Dijkstra. But over here the Dijkstra will change. The Dijkstra will be like 0 and 0 comma like 0 comma x comma y. That's what our priority queue will store. That is what our priority queue will store. Probably a pair of like, तुम लोग struct भी use कर सकते हो, but then comparator का issue हो जाएगा. But there will be a problem because we are using priority queue. So if we use a struct, फिर वो issue हो जाएगा. Let's use a pair of int comma int. So how many of you can imagine a Dijkstra being applied to this maze too? How many of you can actually think of a Dijkstra? How many of you can actually think of a Dijkstra? कितने लोग सोच सकते हो यहाँ पे हम लोग Dijkstra अप्लाई कर सकते हैं? Yeah. Okay. Looks like everyone can. Simple as that. Yeah. I could not, but now yes, you can, right? So what you will assume is, whenever you are here, you move this direction. That means still here. So that is distance, right? That is distance. So probably we can apply Dijkstra. Okay. So we'll be using Dijkstra. टपल यूज करोगे तो फिर प्रायोरिटी क्यू के लिए कंपेरेटर लिखना पड़ेगा, इसलिए मैं गया नहीं उसने में. You have to write a comparator like tuple. मुझे नहीं पता tuple होता है क्या C++ में. I'm not sure. I use pair of pairs usually. No, edge weights. So see, all the edge weights are 1. So if you're here and you roll down to here, 1 roll, 2 roll, 3 roll, 4 roll. Can't you count C++ करके, counter plus करके? You can count, right? But होता है क्या tuple? अच्छा होता है, तब यूज कर लो tuple. Like I'm not sure. I haven't used it any day. Till date तो मुझे कभी ज़रूरत नहीं पड़ा ज़िंदगी में, तो मैंने यूज़ नहीं किया. I'm not sure. But yeah, thank you for letting me know if there is one. Yeah, there is one tuple. Nice. क्या लिखा हुआ भाई? बाद में पढ़ूंगा, छोड़ो, रहने दो. डॉट फर्स्ट होता है क्या? I'm not sure क्या होता है डॉट फर्स्ट डॉट के. Okay, I think we should code this. It's a wonderful question. Let's see how will we code this. हेलो वे गाना बजेगा. ओके आया अभी आवाज आ रहा है, ठीक है। अरे वो हिल गया था, मैं लैपटॉप खींचा ना, वो निकल गया। चलो कोड करते हैं, ठीक है, कोड करते हैं। सो वी हैव अ मेज, वी हैव अ स्टार्ट पॉइंट, वी हैव अ डेस्टिनेशन। ओके, वी नीड अ प्रायोरिटी फॉर श्योर। Yes, I haven't submitted it. This is for sure. Like I have never submitted this problem. I have submitted it. कब भाई? 9/12 कल ही सबमिट किया। 12/9 कब होता है? मैं कब सबमिट किया भाई? हाँ, ये मेरा अकाउंट मेरा फ्रेंड यूज करता है, उसने किया है। Because I don't code in Java at least in a lead code. And my friend has submitted this anyways. प्रीमियम अकाउंट है, पूरा दोस्त के सब यूज करता है। एक दो अरे यार ये कोड होपफुली दिस वर्क्स। लेट्स सी ये इसका डिक्लेरेशन सही है कि नहीं, एक बार देख लेते हैं। इतने ये हो गया ना, मैं परेशान हो गया। हाँ सही, अब डिक्लेरेशन सही। अकाउंट गिव अवे कर दो लास्ट। अरे नहीं, मैंने नहीं किया भाई मैंने नहीं किया, हंसो मत। अरे आई हैवंट सबमिटेड एनीवेज। pq distance, okay, so we require the distance. And now generally how do you solve such kind of problems? Like do you make 2D matrices? Like how do you solve it? Like I generally solve it in this way. I'll tell you this funda, probably this might be helpful in implementing a lot of questions. Like I as a 6-star whatever I am, I generally solve it in this way. What I say is, let's assume this is a 0,0 index, 0,1, 0,2, 0,3, 1,0, 1,1. So what I say is, what if I can probably call this as 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So I generally call it as an integer so that the implementation becomes easier. Now what I can say is, okay, can I say that every row has m columns? I'm like, yeah, that's correct. Every row has m columns. So assuming if this is the row number 1, like if this is the row number 1 and row number 0, row number 1 would already have had m columns. Row number 2 would already have had 2 columns of size m. So can I say, probably I can write I into m, which determines how many columns are there before, plus j. Let's see if this formula works. Assume over here, okay, assume over here this is 2,0. So 2 into 4 plus 0, 8. Understood the formula? Everyone? Has everyone understood the formula? टाइप डिफाइन कर सकते थे, मतलब जनरली आई डोंट डू दैट इन लीड कोड. इट्स नॉट अ गुड प्रैक्टिस टू डू इन लीड कोड. इंटरव्यूज में अच्छा नहीं होता, इसलिए मैं नहीं करता. I today I took 11:30 to 1:30 your class. I did office from 1:30 to 9 around 50, and I'm teaching 10 to 12, and then I'll watch out series from 12 to 3, and then I'll sleep at 4 after ordering something from Swiggy. This is my routine. Lol. Okay, cool. So have you understood this, by the way? Has everyone understood this? I into m plus j, in order to convert a 2D to a 1D coordinate, in order to convert a 2D into 1D coordinate, I am as of now watching Riverdale at Netflix. Has everyone understood how to convert this? सबको आया क्या? Has everyone understood this? Quick, फटाफट बताना. सबको आया? अरे इजी है, देखो 0, 1, 2 3 4 5 6 7 8 9 10 11. सो हर रो में कितने कॉलम्स है? m m m. तो अगर तुम सेकेंड रो पे हो तो 2 कॉलम जा चुका है, तो 2 इंटू एम कर दो, ये 2 कॉलम जा चुके. सो 2 इंटू एम प्लस जे. सो 2 अगर तुम यहां पे हो दैट्स 2,0, दैट मीन्स 2 इंटू 4, देखिए 2 बंदे जा चुके हैं और प्लस 0 से शुरू कर दो, 8 से शुरू हो जाएगा. गॉट इट? अब आया? Got it? So in this way I can convert that into a 1D coordinate. Yeah, we will convert that into a 1D coordinate. I think that will be a better job instead of writing such hectic shits. Instead of writing such hectic shits, we can definitely convert this into a 1D coordinate. That'll be an easier one. And generally in lead code I don't do a lot of type define, otherwise I would have used type define. So in lead code it's considered to avoid type defines. Like, they basically okay, cool. I've taken a pair and pair. Now what I know is I have a starting point and I know that okay, नहीं ये वाला ठीक है, इसको रहने देते हैं. ये हो गया, मेरे पास starting point है, मेरे पास destination है. So let's create a distance array and I know the number of distance will be n into m plus 1 and comma 0, and probably I can just iterate across 0 to n into where n can be called as maze dot size, m can be called as maze 0 dot size. Yeah, that is something which I can definitely take. And what I can do is I can say lesser than equal to something like n into m, and probably I can do an I plus plus, and I can say a distance of I is equal to int max. Yeah, I think that should work. And right after that what I can do is I can say distance of source starting point, start of 0 into m plus start of 1 is equal to 0, and in priority queue you can say push of distance of 0 comma start of 0 comma start of 1. Okay, that is something which I'll do it. So I've pushed it into the priority queue, and now what I'll do is if the PQ is not empty, I will say the dis will be pq dot first ही है शायद, हाँ pq dot first ही है ये तो ऐसे, and that will be x will be top dot first, pq dot top dot second dot first.
I didn't catch that.
Okay, so that's how you can easily, why don't you place directly in the constructor. I'm not sure if vector works like that or not. If you can place it. I'm not sure if vector works like that. Like memset मैं use करता था, I'm not used in vector. Yeah, you can try that out. If it works, it's fine. Okay, so we can keep a dx. Do you remember this method that I taught you the other day? ये वाला मेथड याद है क्या? ओके, वर्क्स. ठीक है ना, चल कर लो वाला चीज. आई एम नॉट गुड दैट लाइक आई एम नॉट दैट गुड सिंटैक्टिकली. Okay, cool. So we have this dx and dy ready. Now what I know is I need to maintain if I'm going across, I need a distance array, right? I need a distance array if I'm going across somewhere. Okay, perfect. If I'm going across somewhere, I need a distance. That's infinity max. I can go to left. So let's take out in all the direction. So I'll go in all the direction, and I can say the new x will be probably, let's keep it as x. New y can be kept as y, and we will go until it's somewhere inside the boundary. New y is greater than or equal to 0, and new x is lesser than n, and new y is lesser than m. and very important, the maze should be having new x and new y to be equal to like 0. You keep on moving. How much do you move? You move by dx of index and you move by dy of index. So once you've reached the boundary, you need to come back via that much distance. Yes, you need to come back via that much distance. So please come back via that much distance. Okay, so once you've done this, can I say this? The number of steps will be counter plus plus. So if I know if the current distance plus the new distance count, by the counter plus plus एक minus हो जाएगा क्योंकि एक पीछे आ जाएगा. If count is lesser than distance of, you're currently at new x into m plus new y. If that's the case, you can make dx and dy static. अरे कर लो जो करना है, बाहर भी रख सकते हो, जो मन है बाहर कर लो, यहाँ रख दो, बेटर है, हर बार डिक्लेयर नहीं होगा. एनीवेज, सो इफ दैट्स द केस एंड ये तो सही है, तो मैं क्या करूँगा, डिस्टेंस ऑफ न्यू एक्स इंटू एम प्लस न्यू वाई को बोलूँगा कि हे डूड, दिस वॉज योर न्यू डिस्टेंस एंड ब्रो you are into the priority queue now. Okay, so in the priority queue I will say I have a pair. In that pair I have another pair, and the first I have dis plus c and t, and over here I have new x into m plus new y. Okay, perfect. And I think I'm done. And at the end, can I reach or not, is that the question? Like, can I reach or not, is that the question? If I cannot reach, what will I put? -1. Okay, so if at the end of the day, if this end point, yes, at the end point, so I know one thing, if I've reached, yes, like I'll do this, I know one thing, if I've reached that point, which is distance of the end point is destination. Okay, that's a destination point, destination of 0 into m plus destination of 1. If you have reached, like, is this equal to int max? क्या हो, pq should be new x new y. Yeah, thank you so much. If that has reached, like if it is still like this, then probably, अरे यार ये ठीक है, -1 रिटर्न कर देते हैं इसको. If that's the case, you will return -1, or else you will return the distance whichever is stored at 0 into m plus destination of 1. This should work. रन टाइम एरर लाइन 1. अरे भाई कहाँ रन टाइम एरर आता है ये? मैं इसको सॉल्व तो नहीं करने वाला, बैठ के भी रन टाइम एरर कहाँ आ रहा है. If you can see some runtime error, line 24 कहाँ डिक्रीज करना है? Error decrease, yes, perfect. Yeah, 12, perfect. Thank you. Yeah, cool, works fine. Hey, let's see what my friend coded. Not sure क्या कोड किया उन्होंने. ओ भाई साहब, क्या लिख दिया उन्होंने? डीएफएस मार दिया उन्होंने तो ना. ठीक है, आई एम हैप्पी, माय कोड इज क्लीनर. I'll get clear. I'll clear the interviews. Naughty. Anyways, what's up first down? So what's up again down or what? क्या बोल रहे हो भाई? भाई चल रहा है. Okay, has everyone understood this? Has everyone understood this? Has everyone understood this? भाई हम ऐसे मत बोलो, व्हाट्सएप डाउन है. या BFS is better. Yeah. Okay, so has everyone understood this? How do you implement DFS? Funda समझ में, logic. You have to imagine a 2D matrix as a graph, and then you can easily solve it, isn't it? Right? You just have to imagine it. And this is a trick that you will always use in distance array. Into columns plus coordinate. ठीक है, थोड़ा सा सब यस यू की कुछ भी लिख दो यार, अच्छा लगेगा. एक बार में ज्यादा मिस्टेक तो नहीं हुआ. यूजुअली यू इफ यू सबमिट दिस यूल गेट. अच्छा, शॉर्ट में बता देता हूँ. देखो मैंने क्या किया. मैंने बोला एक प्रायोरिटी क्यों लेंगे, ठीक है, डिस्टेंस और डिस्टेंस का, एंड फिर अपन डाइक्स्ट्रा लगाएंगे. सो व्हाट आई डिड वाज आई केप्ट अ डिस्टेंस एंड आई सेड एवरीथिंग इज इंट मैक्स. Okay, and after that what I did was I said let's start at this position, and I just converted a 2D coordinate into a 1D coordinate so that I can visualize the graph. After that I kept it dx dy, basically all the directions, left, right, up, down, whatever it is, and then I started the Dijkstra. And what I said is अगर यहाँ है चल इस डायरेक्शन में, चल इसमें, चल इसमें, चल इसमें, जहां तक जा सकता है जा. And the moment it crosses, if the while loop is over, it will cross the bound, like boundary cross होगा या 1 में पहुंच जाएगा. तो एक माइनस कर दो क्योंकि बाउंड्री क्रॉस हो चुका है. वापस आ, बाउंड्री नहीं क्रॉस करना, बाउंड्री से पहले थम जाएगा. तो एक पीछे आ जाएंगे और काउंट को कर देंगे. तो उतना स्टेप मैंने गिन लिया. अब मुझे क्या पता है यहां से यहां जाने में इतना स्टेप लगेगा, तो ये एज वेट हो गया, तो इसको एक्स्ट्रा की तरह ट्रीट कर दिया एंड फिर पुट कर दिया डिस्टेंस ऑफ प्रायोरिटी क्यू में. बन गया एक्स्ट्रा का सवाल. क्लियर है? Okay, next question. Like I'm not sure why is that lead code, at least lead code medium तो नहीं है ये मेरे लिए. मेरे से क्वेश्चन, मेरे से डाउट मत पूछा करो यार, मैं बहुत थक जाता हूँ. तुम सोचो मैं सुबह से पढ़ा रहा हूँ. लाइक यू सॉ ना, आई टुक अ क्लास एट 11:30 AM in the morning. I then did office and then again I'm taking a 2-hour class. अब इसके बाद मैं, मेरे पास हिम्मत है डाउट किसी का सॉल्व करने का? खुद सोचो, खुद का डाउट नहीं सॉल्व करता मैं. Okay, I want you to read this question. Number of ways to arrive at a destination. I think this should be visible to everyone. Is this visible to everyone? Is this visible to everyone? गला मेरा कटा हुआ था, देख रहे हो? ये देखो मेरा इतना गला कटा हुआ है, ये देखो. दिस कर लेते हैं, जब तक उम्र है तब तक मेहनत कर लेते हैं, और क्या है, मजा आता है एक्चुअली. Yeah, no, I had a tumor over here. 6 months back. Over here, I had a big tumor. So I went into operation where this was cut off. So yeah. Okay, bye. Yes, I did explain. I did explain this question. But for people who are new, we can definitely solve this problem. Look, I'm assuming ग्राफ जो देखने आ रहे हो वो लोग उस स्ट्रीम पे नहीं होंगे. Okay, if everyone who watched this problem, you can drop off definitely. It's a very good extra problem. Okay, please read the problem, and I'll get started. Okay, go through the question and tell me if you've understood this. I'll give you a couple of minutes. Go through the question and tell me if you've understood this. Okay? डीएफएस के ये देखो, हर क्वेश्चन जो बीएफएस से होता है वो डीएफएस से होगा, हर क्वेश्चन जो डीएफएस से होता है वो बीएफएस से होगा, समझ रहे हो? सो आई एम समवन हु लव्स अ लॉट ऑफ डीएफएस, सो आई यूजुअली यूज डीएफएस बिकॉज इट्स इजियर टू थिंक. सो या, आईफोन 13 नहीं भाई, आईफोन 12 ही है, पुराना वाला ही है, आईफोन 12 ही है. क्यों लेना है, ये 3-4 साल चलेगा यार, ऐसे कुछ काम नहीं होता मेरे पास फोन का. आई डोंट यूज फोन दैट मच, पड़ा ही रहता है. Yeah, DP. It's kind of a DP. Okay, how many of you have heard about like how many of you understood the question? ग्राफ के लिए if you do 10-15 questions, भाई आपकी लाइव क्लास कब होती है? कोई श्योरिटी नहीं, जब मन करता है आके ले लेता हूँ. ओके, लेट्स अंडरस्टैंड द क्वेश्चन. मैं पहले इसको बना लेता हूँ, मतलब इसको मैं ड्रॉ कर लेता हूँ. तुम लोग फटाफट क्वेश्चन समझो, फटाफट क्वेश्चन समझो. लास्ट क्वेश्चन फॉर द डे. Okay, let's understand the question. So you will be given, you can follow the SD sheet style, follow the SD sheet. So you will be given a graph. Okay, so assume this is the graph, and this is the starting point will be 0 and the ending point will be n minus 1. The starting point will be 0 and the ending point will be n minus 1. Okay, now if you are at 0, yes, if you are at 0, what is the minimal way that in which you can reach? So you will be like, if I take this direction, that will take me a distance of 7. Okay, so there's one path which takes a distance of 7. There's another path which again takes a distance of 7. So there are two paths. Is there any other path? Is there any other path? 2, 3, yeah. There's one other path which takes a distance of 7. 3 paths. Is there any other path? 2, 3, 1, 1. There's the fourth path which takes a distance of 7. So in total, the minimal distance that is taken from 0 to 6 is 7, and the number of paths that take the distance 7 are 4. So they want the minimal value, the number of paths, which is 4. Question UQ. Gaming with engineering. See, it's not about solving 600 problems, it's not about solving 1000 problems. As long as you don't take concepts, you'll not be able to solve a single problem in the interview, right? It's not about solving 100 question galya. Nahi, it's, see, if you're doing the extra, do it in such a way that if I give you any question, you can implement the extra on it. Then you should be comfortable. Solving 600 से क्या ही होगा यार, मतलब डेक्स्ट्रा का अगर मैं 5 सवाल भी करता हूँ लेकिन मैं अच्छे से करता हूँ तो मुझे कोई भी, आज मैं आई हैव डन डेक्स्ट्रा सच इन सच अ वे, गिव मी एनी क्वेश्चन ऑफ डेक्स्ट्रा, आई विल सॉल्व यू. यू शुड बी दैट मच कॉन्फिडेंट, राइट? डोंट जस्ट से कि मैं 400 करने वाला हूँ, 500 करने वाला हूँ. क्या होगा उससे? कॉन्सेप्ट पे फोकस करो. एक कॉन्सेप्ट उठाओ तो उसका इतना, मैं ऐसे नहीं बोला रट जाओ, ऐसे ऐसे सवाल करो जो कॉन्सेप्ट बिल्ड करे. ऑलराइट, 8 वाला पाथ नहीं लेना है ना, 8 वाला पाथ नहीं लेना है. यू वांट द मिनिमल डिस्टेंस पाथ, यू वांट द मिनिमल. देखो ये वाला डिस्टेंस 8 ले रहा है ना, मुझे तो मिनिमल चाहिए. द मिनिमल डिस्टेंस इज 7. कितने लोग 7 डिस्टेंस ले रहे हैं? राइट, गॉट इट? कार्तिक सिंह कुशवाहा. How will you do this? Anyone with an idea? How will you do this? How will you do this? Number of ways. How will you do this? कैसे करोगे? You guys understood the question, but how will you do this? That's my question. That's my question to everyone. How will you do this? Generates, okay. No. That will take a lot of time, Vimash, don't you think? So Vimash is saying generate all the paths from 0 to 6. That will take a lot of time. If you try out every other path from DFS, it's gonna take exponential time, definitely, because you're trying every path, right? What's a better way? Okay, let's understand. I'll just help you out with this. How many number of ways are there in which you can reach 0 to 3? क्या होगा इसका आंसर? इसका आंसर क्या है? इसका आंसर क्या है? What's the answer? What's the answer of this? What's the answer of this? Yeah, 2. Yeah, 2. How did you know 2? How did you know 2? How did you know 2? Let's understand. जब तुम इधर से आया, तुमने बोला यहां तक पहुंचने का जरिया एक है. When you came here, you said यहां तक पहुंचने का जरिया एक है. There's only one way in which you can reach here. When you came from here, you said this guy, to reach here, the number of ways is 1. So I will take a distance of 1 and 1. So distance will be 2. So in order to take distance 2, if this guy is taking one way, this guy will also take one way. Now, but the moment you see this and this, you see 1 and 1, another 2. So this is again one more. So you'll say there are 2 ways in which you can generate 2 possible ways. So you basically took how many times the same distance is being coming. The same distance is coming. Not an issue. I'll give you one more example. Okay, let's understand now. A quick question. How many ways on this? 1, 1, 1. The number of ways in which you can reach here, here, here. Is that 1? Do you agree? Is that 1? How many of you agree that it is 1? How many of you agree that it is 1? How many of you agree that it is 1? How many of you agree that it is 1? क्योंकि यहां से मैं वन डिस्टेंस ही तो लूंगा, तो सारे में पहुंचने का एक ही तो जरिया है. यस 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 और नो? डू यू अंडरस्टैंड? यस. You can just have one way to reach these guys, these nodes, right? So how many ways do you have to reach this? How many ways do you have to reach this? In how many ways can you reach this guy? In how many ways can you reach this guy? कितने ways हो गए? And how many ways can you reach this guy? 3, yeah, absolutely. 3 ways. Because if this is 1, this is 1, and this is 1, there will be 3 ways. What if I make this guy 0 and ask you, now how many ways are the shortest ways in which you can reach here? How many ways are the shortest ways? Like, what's the shortest, like, अभी क्या होगा ways जिसमें तुम minimum पहुंच सकते हो? There's only one now, which is this. There's only one, because all these are taking 2, 2, and this is taking 1. There is 1 now. Okay, there's 1. You need to understand. So you need to basically store in how many ways can you reach a particular node when it gives minimum distance. Okay. So I'm saying the ways is 3. Perfect. Ways 1, ways 1, ways 1, ways 3. So in how many ways can you reach this guy? In how many ways can you reach this guy? In how many ways can you reach this guy? अब इसका ways बताओ. In how many ways? कितना? Yeah, yeah. So, what did you understand? What did you understand? What did you understand? If, like, we were doing Dijkstra, whenever the distance was smaller, we were inserting into the priority queue. But over here, if the distance, yes, if the distance is equal to, we'll just add up the weights. There's no need to put into the priority queue. We'll just add up the weights. Let's understand by doing a dry run. But have you understood the intuition of weights? How does weights adding up? How does weights add up? Have you got the intuition of how does weights add up? Now I'll show you the dry run on this, but have you understood the concept? My main focus was the concept. So have you understood the concept? कॉन्सेप्ट समझ में आ गया क्या? कॉन्सेप्ट आ गया क्या समझ में? पहले ये बता दो, फटाफट मैं अभी ये समझा दूंगा. Okay, so everyone has understood. So what I'll do is now I'll tell you how to basically solve this. So distance will be there. Okay, let's keep a distance. Okay, this will be the distance, and let's keep a ways. So this will be the ways. Okay, this will be the ways, and the ways will be initially. Can you tell me, in order to reach here, how many ways do you require? In order to reach the source, which is 0 initially, how many ways are there in order to reach the source? It's very simple. It's 1. Okay, that's the initial configuration that you will have. That's the initial configuration that you will have. ठीक है? अभी आगे अपन क्या करेंगे मैं बता देता हूँ. वैसे चैनल को सब्सक्राइब कर देना if you are new. We will take a priority queue. Similar. We'll take a priority queue. ठीक है? Next, you will insert 0, 1, saying that this is the smallest one. Let's take that out. So you're saying 0, 0, 0. You're saying 0 distance taken to reach the node 0. From 0 I can go to 4, which will take me a distance of 5. So total of 5. So in 4 I can do a 5. And I can say that, hey, listen, in order to reach 0, the ways were 1. So in order to reach 4, the ways also will be 1. From 0, I can also go to 6. Now what I see is the distance is 7. Now 6 says, okay, 7. So the ways will be 1 because over here the ways is 1. So the ways will be 1. Perfect. So by the way, just make sure the distance 5, 4, the distance 7, 6 is inserted. Okay, just make sure you do that. Right after that, I'll be like, where can 0 other go? It can go to 1. And 1 will take a distance 2 and the way is 1. So distance 2 and you can go to 1. That's how 1 will work out. That's how the first iteration will work. First iteration is over, you can just erase it. So I've stored down this particular stuff. Next, 2, 1 will be taken. So I'm taking a distance of 2 in order to reach 1. And how many ways are there? The ways are 1. Perfect. From 1, where can you go? You can go to 0, which is not considered because the distance will be more. From 1, you can go to 3, which is 3. So it's 5. 5. How many ways? Obviously 1. So 1 over here. From 1, you can go to 2. Again, distance 5. And this time the ways is 1. Okay, perfect. So basically I will come up with 5, 3 and 5, 2. Amazing. So this is also done. Next. Which one is the next? The next will come out to be 5, 2. So 5, 2. Now you had 5, 2. So you'll be like, अब यहाँ से मैं कहाँ जा सकता हूँ? The number of ways are 1. So from 2, where can you go? From 2, you can go to 5. You can go back to 1. But this will not be considered. And this will be considered. Where you say that to go to 5, the distance is 6. And the number of ways is 1. So distance is 6 and it is 5. So yeah, you can just write it. Okay, cool. This is what we are left on in the priority queue. So what I will take is 5 comma 3. 5 in order to reach 3. Now let's see. So from 3, where can you go? You can go to 6, but that will take a distance of 8, which is not to be considered. From 3 you can go to 1, which is again not considered. From 3 you can go to 5, and let's understand the ways was 1. The ways was 1, but from 3 to 5 the distance is 1. So you take a distance of 6. 5 is already having a distance of 6. So ये way क्या करेगा? What will happen? What will happen if it is already having a distance of 6? Can you tell me what will happen? Can you tell me what will happen? Can you quickly tell me what will happen? Yes, you just need to increase ways. Amazing. You just need to say, hey, there's one more way with distance 6. There's one more way with distance 6. I'll be like, oh, perfect, perfect. That's amazing. Let's erase this again. So I'll erase it. And the moment I've erased it, I'll just take the next guy. The next guy is definitely 5 comma 4. So in order to reach 4, it's 5. So in order to reach 6, 1 will not be considered. That's a distance of 7. 6 is already having 7. So I'll say 2. Perfect. This is also done. Remember, whenever it's the same distance, you don't put it into the priority queue. Whenever it is the same distance, you don't put it into the priority queue. Okay, next. 6 comma 5. 6, 5. 5 कहाँ जा सकता है? 2, 3 दोनों कंसिडर नहीं होंगे. 6. Again I get 6. 5 का ways कितना है? 5 का ways are 2. So in order to reach 6, you'll require one more, which is 7. So in order to reach 6, you are requiring 7. So how many ways will you increase? 2. So this will become 4. So you can just keep on doing this. And did you understand how did this work? You have to a priority queue use. क्यों किया इतना देर से क्या कर रहे थे हम लोग अभी तक क्या कर रहे थे? It's a modified extra. You don't use priority queue, it will take a lot of time, right, Sahil? Priority queue तो इसीलिए यूज कर रहे हैं ना, because queue में I did tell you ना in this logic, यहाँ पे बताया था ना क्यों यूज कर रहे हैं, याद है ये वाला logic? Remember this logic? You will and unnecessarily you will ask the queue to do a lot of tasks. Y plus 2. अरे पवन अभी तो समझाया. अगर यहां तक तीन तरीके में पहुंचे हो तो यहां भी तो 3 तरीके में और पहुंचोगे ना. तो अगर 5 तक 2 तरीके में पहुंचे थे तो 5 से जब 1 जोड़े और 6 में पहुंचे तो वही एक तरीका 2 तरीका होगा ना. तो ये दोनों तरीके से तो पहुंचोगे 7 पे. गॉट इट पवन? गॉट इट पवन? Got it? Done, got this? क्योंकि देखो 5 पे अगर मैं 2 तरीके से पहुंच रहा हूं तो 5 पे अगर 2 तरीके से पहुंच रहा हूं तो 7 पे भी तो 2 ही तरीके से और पहुंचूंगा ना. तो वो 2 का ऐड कर दो तो यहाँ 4 हो जाएगा. Okay, everyone, can I get a UQ? And then I'll probably I'll just code this super quick and then we'll wrap up the class. Can I get a UQ? Super quick. UQ from everyone? Okay, no issue. Sahil, you can watch the lecture. It'll get uploaded. You can watch the lecture. It'll get uploaded. Okay. So I think the extra should be now very clear to everyone, isn't it? So remember, you have to print all the answer modulo 10 to the power 9 plus 7. And the extra should be super clear to everyone, isn't it? Right. Okay, perfect. So number of ways is what you need to compute. So probably I'll keep a INT ways. Not sure INT ways काम करेगा कि नहीं, but still I'll probably keep it. Someone said me to use this, so I'll use this. Okay, so I can say the distance of the source is 0 and the ways of the source is also 1, because that's the only way to reach here. अपलोडिंग आपको करना पड़ता है क्या? नहीं, मैं नहीं करता यार, टीम में, इसलिए तो मैं इस चैनल पे ज़्यादा पढ़ाता हूँ. मुझे कुछ नहीं करना पड़ता, ना थंबनेल ना कुछ. मैं आता हूँ, क्लास शुरू करता हूँ, लेता हूँ. कोई मेहनत नहीं होता इसमें. तो मेरे चैनल पे मेरे को डबल मेहनत करना पड़ता है. थंबनेल बनाओ, सब कुछ करो. ओके, सो where was I? I have to do Dextra, right? Okay, let's do Dextra. So while okay, I have to declare a priority queue. Definitely priority queue pair of int comma vector of vector में pair डाल देंगे, greater में भी pair डाल देंगे, and ये pq. So I'll just take this pair and put it into the vector as well as into the greater. So pq is done. So pq dot push and the distance will be 0 comma it'll start from 0. So while pq not empty, and you can say int node is equal to pq dot top dot second, and you can say the distance is basically dis equal to pq dot top dot first, and you can do a pq dot pop. हाँ, ग्राफ सीरीज देखिए, देखोगे तो इजी लगेगा. यहाँ पे प्रॉब्लम सॉल्विंग ज़्यादा मैं फोकस कर रहा हूँ. Okay, for after this, what you will do is you will iterate for all its adjacent. Okay, so by the way, the roads are given like this. Okay, the roads are given like this. You have to create the, yes, you have to create the what to say, basically you have to create the map, sorry, the graph. So make sure you create the graph. The graph is created. Once the graph is created, you can just simply go on like this, and you know the weight will be it dot second. The adjacent node will be it dot first. Okay, so that's what you can take it. And what you can write is, if weight plus distance is lesser than distance of the current weight, then what you can do is, like, sorry, okay, distance of it, then you can say distance of it will be weight plus dis. The ways of it will be ways, will be ways of node, and at the same time you can say pq dot push रोड के प्लेस पे एडजेसेंसी आएगा ना. क्या हुआ, मैं थक गया यार बहुत ज़्यादा आज, बहुत थक गया, बहुत काम किया मैं. pq dot push, what will you push? डिस्टेंस ऑफ it गया, वेज गया, क्या पुश करोगे? मैं डिस्टेंस ऑफ it पुश करूँगा, राइट, एंड अपन पुश करेंगे एडजेसेंट नोड. Okay, so I push that, and I think that's done. And else if will be, if weight plus dis is equal to distance of adjacent node, just make sure you do ways of adjacent node will be equal to ways of adjacent node plus ways of the current node, and the modulo mod was given, so you have to do a modulo mod, and then this should be the answer. Yeah, return ways of n minus 1. Yeah, एलियंस वाला प्रॉब्लम से लास्ट क्लास में करेंगे, अभी फायदा नहीं है करके. अभी थक गया हूँ, तुम भी थक गए हो, आराम करो. अरे आजा, रन टाइम एरर. अरे यार उस दिन भी आया था ये रन टाइम एरर, क्यों आता? 1000 plus 2000, अच्छा, cannot be represented. You have to take long probably. Yeah, you have to take long. Why mod? Because the question stated mod. Because the question stated mod. Why mod? Because the question stated mod. That's the reason. क्या बोल रही है? कैरेक्टर रनटाइम मिरर साइन कैन नॉट बी रिप्लेस. ये कितना बहुत बड़ा है क्या ये? इंटीजर ओवरफ्लो हो रहा है भाई साहब. कितने जीरो से? 3 3 6 क्या हो रहा है? डिस्टेंस ओवरफ्लो. रॉन्ग आंसर. ओ गुडनेस गुडनेस, रॉन्ग आंसर क्यों है? लॉन्ग 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 करना पड़ेगा अभी इसको. परेशान हो गया मैं तो. Anyways, like most of you have understood, right? Most of you have understood, right? इसका सही कोड मैं दे दूंगा, मैं बस पहले किया हुआ था. बवाल नींद आ रहा है मेरे को. ये लास्ट ट्राई है. चला तो चला, नहीं तो घर चलेंगे. और कहीं एंड है क्या? और कहीं एंड तो नहीं लग रहा मुझे. ओके हाउ टू अप्रोच फॉर रेफरल. इसका अलग से सेशन थोड़ी लेता है कोई. अरे गाइस, yeah, that is कर सकते हो, मतलब कर लेना जैसे भी करना है. चलने से मतलब है. मैं इसका कोड दे देता हूँ. आज का सारा कोड इधर है. मैं उसका भी दे देता हूँ. और एक क्या किया था अपने, रैट एन मेज किए थे, राइट? मेज 2 का भी कोड दे देता हूँ. और कुछ किए थे क्या? या मेज 2. अच्छा ये कोड था मेज 2. क्या सर, ये मेरा कोड था, वो नहीं था. ये भी मेरा कोड ही है. एनीवे सही है. इसको मैं ID1 पे चिपकाता हूँ. क्या मानना पड़ेगा भाई? मजा आया? बस एग्जीक्यूट दैट कोड. बोरा गया क्या बंदा? प्रोग्रामिंग इन सी बोरा गया हो क्या? अरे अरे एग्जीक्यूट करके सबमिट भी तो किया. ए बेस्ट नहीं, ये नहीं सुना. ये नहीं सुना. This is the ID1. This is the ID1. Just use this in the ID1, you'll get it. ये वाला ID1 में खोल लोगे तो कोड मिल जाएगा. ठीक है भाई. इसको कोई समझाओ. प्रोग्रामिंग इन सी को कोई समझाओ. कोई समझाओ. अरे डूड, इट पास्ट मैन. ये थोड़ा पास तो किया है. ये क्या है? ये क्या है? ये पास नहीं तो क्या है? पास. भांग भांग पी के रखा है क्या भाई? पास तो कर लिया भाई. डोंट वरी, डोंट लीव. ये मुझे मजा आया आज. डिड यू एंजॉय द क्लास? डिड यू एंजॉय द क्लास? हाँ सोएंगे थोड़ी देर बाद. अरे वो लिंक, यू कैन नॉट सेंड ID1. यू कैन नॉट सेंड ID1 लिंक इन द चैट. सो या प्लीज खुद से टाइप कर लो. थोड़ा मेहनत कर लो, खुद से टाइप कर लो भाई. मजा आया? ओके. सो मेक श्योर सारे प्रॉब्लम कर लेना. कल DSU करेंगे. कल और मजा आएगा. मतलब एक लेवल ऊपर. कल एक लेवल ऊपर आएगा. ठीक है. नहीं अभी अभी थोड़ा वो रिवरडेल देखेंगे. आई वॉच नेटफ्लिक्स. मतलब मुझे वैसे कुछ काम नहीं रहता रात को. रिवरडेल देखेंगे. दिस इज द सीरीज दैट आई एम करंटली वाचिंग ऑन नेटफ्लिक्स. दैट इज समथिंग व्हिच आई विल वॉच. एनीवेज गाइस, गुड नाइट, टेक केयर, बाय बाय. फ्लाइट डिस्काउंट बाद में देता हूँ यार, और नहीं है हिम्मत. प्रॉब्लम आज का बहुत हो गया. गुड नाइट.